Okay, so today we're going to start off by talking about calculating the turning point of a quadratic equation. So when we're calculating the turning point, what we're really doing is we're using a certain part of the quadratic formula to help us find where the middle of the function is. We then find the coordinate of that function by putting the x value back into the function and finding the y value. So if you look here at this equation, this one, you can see this is just the quadratic formula. Now, if I separate this out into its two parts, I'm going to get this. So all I've done is I've split the two terms on the top so that there's two denominators here. They mean the same thing. Okay, so if you look here, this part, helps us find the location of the middle of the coordinate. This part here, once I found the middle, so that's the middle, it's going to tell me how far left and right to go of that to get my intercepts. That's why your quadratic equation works, to help you find the roots of an equation. It finds the middle and then it splits the difference either side of it. So here, that first part helps us find the middle. So when we're looking at the turning point formula, we're looking at calculating the x coordinate of the center, and we put it back into the equation to find the y coordinate. So I'm going to do this one as an example. So let's say that I've got E.g. My equation is going to be y equals minus 3x squared minus 5x plus 2. Now, my first step here, you can see that there's a's and b's in here. Now, that's referring to the a's and b's in this equation. You assign them the same way that you would for the quadratic formula. So here, a equals the thing in front of x squared, so minus 3. B equals the thing in front of x, minus 5. And c equals the constant on the end, so just 2. Okay, so now I'm going to substitute it into my equation. So each time we use FSA, so I'm going to state the formula, remembering that this will give me a coordinate. Now the easiest way to solve this is to do this first part and then get your answer, substitute it back in here. So I'm going to do minus, bracket for when I substitute in, minus 5. If you don't use brackets, things will go wrong. 2 bracket minus 3, comma. Now I'm going to keep solving this one. So the top here will become positive 5 over the denominator here will be negative 6. So that's the number that I'm putting back into my original function here. Because remember, I could say this as y equals, or I could say it is our function at the point where x is this number. So now I'm going to substitute back into this function when x is 5 over negative 6. So our x coordinate is this, and now to figure out the y coordinate, I'm putting it back into the function. So minus 3 bracket 5 over negative 6 squared minus 5 bracket 5 over negative 6 plus 2. So now I'm going to keep going. So I'm going to state my x coordinate again. Okay, and now I'm going to go through and simplify this. Now, if it was in one of our exams, you guys would have nicer numbers here and here. But if it's a calculator allowed exam or a scientific calculator allowed exam, then you might just be able to do this. So from here, I'm just going to plug it into the calculator. Okay, so once I'm into this calculator, executing the run matrix, then I'm going to put in that function as I see it. So negative 3 bracket 5 over negative 6 to the power of 2 minus 5, 5 over negative 6, plus 2. Okay, and so that gives me an answer of 4 point. Now, that is going to be 0.8 if I go to 2 decimal places. Now, it's weird that I've done that. If I wanted to change that to be a fraction, all I need to do on this calculator is press F to D. So as a fraction, it would be 49 over 12. So if I want to leave it as fractions, it'll be 5 over 6 and 49 over 12. I could also convert this first one to being a decimal. It's definitely easier to graph if you've got numbers like this opposed to fractions like that because you can see exactly where they should go on the graph. Okay, try to calculate the turning point for these 5 functions here. And then I would like you to check on your graphics calculators by graphing them and then solving for the turning point. So to do that, you'll go graph. I'll enter in my equation, x squared plus, minus 3x squared minus 5 plus 2. Execute, draw it, then go G-solve. And then for this one, if I'm trying to find the turning point, I'm trying to find the maximum spot. So max. There it is when x is 0, y is negative 3. Something has gone wrong. Yes, okay. Make sure your function's input correctly. So draw it. Now G-solve. That one is going to a max because see how it's got a maximum point on the graph. So yep, when x is negative 0.833333, y is 4.08333. So I've confirmed that that is my turning point. Okay, so go through and do these 5, check on your calculator.